Geometry Pre-Cal, we're talking about section 13.1, which is about counting. Our goal is to talk about probability, but probability is where we count the favorable outcomes and we put that over the total number of outcomes. So if we aren't good at counting the total number of outcomes or the favorable outcomes, then we can't do probability. So this section is about counting, and it starts with sets. So we have a couple of vocabulary things right here, stuff you've seen before. Union, which is abbreviated with this little U-shaped symbol, means where we throw everything from more than one set all into a single set. Intersection, it looks like a little rainbow, an upside down U. That's only what they have in common. This 0 with the slash through it, that's the null set. It's also called the empty set, and that's what we write when there's nothing in the set. And then X bar here, we're going to put the name of our set, and then when it has a bar over it, that's the complement of the set. So it's everything not in the set. This should remind you of the word in geometry, complement, when two things add up to something else. So this is what's going to happen. We're going to list, they're going to give us one set, and we're going to tell all the stuff that's not in it. So together, we get a complete list. So I'm going to do a couple of examples, short ones, because I don't want to be doing this all night long. So A, I'm going to call it 1, 3, and 7. Set B, we'll say is 1, 5, and 9. And then set C, just 3 and 4. So we have our three sets. First thing I want to find is their union. So if I do A union B, so that U symbol, that means everything that's in this set or this set will get put into this one. So there's a 1, there's a 3, there's a 5, there's a 7, and there's a 9. Normally, your textbook, most people are going to make an effort to put those in order, but that's not mandatory. So I wrote mine in order, but if you had just written 1, 3, 7, we've already got the 1, so we don't have to write it again. 1, 3, 7, 5, 9, that would still have been correct, even though it's not in the same order. Okay, second, we're going to do the intersection. So A intersect B. That's only what they have in common. So this has 1, 3, 7. This has 1, 5, and 9. The only thing they have in common is a 1. That's the only number that's in both sets. So we get A intersection of B is just the 1. Okay, now we're going to do B intersection C. So B intersects C. What do B and C have in common? 1, 5, 9, 3, 4. They have nothing in common. That's where we use this little symbol that just means none. So there's none numbers in common. So we put our null set or empty set symbol. Okay, sometimes they get real big and they kind of do a lot at one time. Eraser. So we're going to do a little bit more complicated one, but we're just going to use the same order of operations we've always used. I erased most of the A, B, and C. That was a little bit annoying. Okay. So A was 1, 3, 7. B was 1, 5, 9. And C is 3, 4. So what we're going to find is A intersect C union B. So there's a lot more in there this time, but we still do it one step at a time, and we do it with our order of operations. So because this is in parentheses, this is what we do first. So the intersection of A and C, 1, 3, 7, and 3, 4, well, that's just 3. So I've done this part. Now where does this answer? And we put union B. So 3 union B, which means we write everything that's in either set. So 1, 3, 5, and 9. Everything from this set, everything from this set, all combined into a single set. And again, we traditionally write them in order, but that part isn't mandatory. You don't have to write them in order. They're going to make the problem a little bit different when we do complements. So when we're doing our complement, we're doing what's not in the set. Well, that would be an infinite list. What's not in the set 1, 2, 3, every other number in the world, which is an infinite list. So what they're going to do is they're going to give us something called the universal set, and they'll sometimes give us the U. So what they're defining is all the numbers. So if our universal set, it's usually a pretty long list. So let's say it's 2, 4, 6, 8, 10, 12. There's our universal set. A is 4, 8, 12. And B is 2, 12. All right, when we find a complement, the complement of A is all of the numbers from the universal set that are not in A. So that would be 2's not in there. 4 is, 6 is not, 8 is, 10 is not, 12 is, so we're done. So 2, 6, and 10, that's the complement of A. The complement of B is everything not in B. So the bar over the top is telling us to do the complement. We would get 4, 6, 8, 10. That's all the things that aren't in set B. And then you're going to be asked to combine this idea with the stuff that we had a second ago. So you might be asked, for example, for the complement of the intersection, I wrote C, of A and B. The complement of the intersection. Notice the bar is over the intersect symbol. So we want the complement of the intersection. That means we need to do the intersection first and then find its complement. So first we find what these two have in common. So what's in both? They both don't have a 2, they both have a 6, and they both have a 10. So this is the intersection part, and we want the complement of that. So everything that's not in the intersection. So that would be 2, 4, 8, 12. They can also write it like this. We'll do union this time. So this is the complement of A, union complement of B. Notice that this time the bar is not over the symbol. It's only over the A and the B. That means we want the complement of this and the complement of this, but not the complement of the union. So we do the complements first. So that means the complement of A we already wrote is right here. The complement of B we already found right here. So the union of complement of A and complement of B is everything that's in either list. So 2 is in there, 4 is in there, 6 is in there. It's in there both times, doesn't matter, we still only write it once. 8 is in there, 10. Again, 10 is in there twice, but we don't write it twice. Once again, I put mine in order. Your textbook is going to do that in the answers, but that part isn't mandatory. It does make it easier for you to check your answers because that's how they're going to be written. Okay, so union, intersection, null set, and complement. That's what we needed to learn about set notation. We've got 3 major topics, and they get shorter from here. And none of them should be completely foreign. A lot of this should be at least a little bit review. You might not have done the complement before like this, but union and intersection, hopefully all are familiar. Now we're going to talk about the word subset. This is going to be a quick one. We're just going to list all the subsets of something. So I'm going to use symbols this time just for a little variety. So our set is circle, triangle, square, question mark. There's our set. And we want to find all the subsets of this. All the possible subsets. Well, we start by listing all the possible sets with only one thing in them. Circle, triangle, square, question mark. This isn't mandatory, but this is a good way to keep track and make sure we've found them all. So I've got all of the subsets that have one element. Now we list all the ones that have 2 elements. So we do all the possible combinations of 2 things. So circle and triangle, circle and square, circle and question mark. Triangle and square. Triangle and question mark. Notice I don't go backwards. Circle, triangle, and triangle, circle are the same set because the order doesn't matter here. Okay, so we've got all the ones that start with circle, all the ones that start with triangle, square, question mark, and then we can't do any that start with question mark because those have all already been done here. So triangle, square has already been covered, or sorry, question mark, square has already been covered here in the other order. Question mark, triangle has already been covered here, again in the other order. So once we've got all the sets of 2, we move on to all the possible sets of 3. This is a little trickier and it takes a while, but this is how you list all of the subsets. So we go circle, triangle, square, or possibly circle, triangle, question mark. Okay, how about circle, square, question mark. You just go through the list one piece at a time. All the sets that have 1 element, all the sets that have 2 elements, all of the sets that have 3 elements, and finally your last subset is going to be the whole thing. So the last one you list is going to be all the subsets of 4 elements, which is actually the original. That's how we list all the subsets. It's lengthy, but it's not hard. So you just make sure that you have all the combinations, and remember that order does not matter. So once you've listed it once, you don't have to list it again in a different order. The last thing in this section hopefully is really familiar, and it's a Venn diagram. So this Venn diagram is also going to have that U for the universal set. That's the whole picture. And then it will have some amount of circles that overlap. They'll name the circles, usually with letters like A, B, and C, but they may have more specific names like boys and girls, or 3rd grade class and 4th grade class. We're just going to call ours A, B, and C. And then we'll have numbers in all of these little sections, and we'll be asked to answer questions about them. So what we're looking at is the number of things in each area. So we might be asked, for example, how many are in none circles? That would be 6. How many are in circle A? That would be everything inside this border. So 6 plus 3 plus 2 plus 7 makes 18. There are 18 in circle A. How many are in circle C? We find the border to circle C. 4 plus 8 plus 6 plus 7. So this time we've got 18, 25 in circle C. They will ask you about overlap. How many are in both circle A and circle B? Well, that would be this part here, because these two numbers are in circle A, but they're also in circle B, so there are 9 total that are in A and B. How many are not in C? How many are just not in C? Well, we'd have to add up the 2, the 3, the 5. Those are not inside the border of circle C. And then don't forget this one too. So 16 total, because these 6 outside of all of the circles are also not in circle C. How many are in all 3? That's only 6. That number in the middle overlap. You've probably done these a bunch of times before, probably since elementary school, but it never hurts to have a refresher. ACT likes these too. Okay, that's all that's in the first section of chapter 13. Then it moves on more to probability. So we kind of get introduced to sets because sets are related to probability. Before we do the next sections, make sure that you have a calculator when you get started, because it's a lot of calculator work and you'll need those buttons.